Former Lurker here. Hi everybody, it has been a while since I posted a new video, and it's not because I haven't been working on Octolapse. It's actually because I've been working too much on Octolapse, and it's been very hard to drag myself away from the coding to give you some new content. And if you're one of my patrons on Patreon, you're getting access to this video a little bit earlier than everybody else. Thank you so much for your support. If you're not a patron and you want to support Octolapse, and I can tell you it helps a lot, there's a link to my Patreon page below. Please check it out, and if you can, give me a little donation. It really helps. It's pretty expensive to work on 3D printers, and it's even more expensive doing development and getting equipment to test, and it takes a lot of time, and I really appreciate it. So now with that out of the way, I wanted to post this video to kind of show everybody what I've been working on, the new features that I've been adding, and to get a little bit of feedback on how everything looks, and hopefully to make everything better. Now I've been focusing on three things in this new version, and it's the three most common complaints I hear about Octolapse. The most common is it's too difficult to set up, and I couldn't agree more. I even have trouble sometimes figuring out what settings to use and remembering what G-code file I've used and making sure I've copied it all. And sometimes I have a time lapse that goes and it's not what I expected it to be. So I've tried to simplify the setup a little bit in this version. The second most common complaint I get is that it adds too much time. Octolapse adds too much time to the print, and it is proportional to the number of layers. So depending on your object, it could add a lot of time. It might not add a whole lot of time, but there are definitely ways to improve that and to reduce the amount of time that Octolapse adds. And the third most common complaint I get is print quality. And this is really the one I'm most concerned about personally, because I honestly want to get this program working to where there's almost no impact at all on the print quality. And depending on your printer and the material, that's kind of achievable today, but it's really hard to get configured and it's hard to tweak your printer, and some materials don't play nice anyway. So I've been working on all three of those, and I want to go over some of the changes I've made in those three areas. So let's start with number one, and that is configuration. So the first thing you'll notice, one of the profiles has completely disappeared, the snapshot profile. I've actually merged it with the rendering profile, and I'll get to why later, but it actually does simplify things a little bit. There's just one fewer thing to click on. Now, probably the biggest improvement, though, that I've made in getting the settings a little simpler is I've added a new slicer type. So let's look here in the printer profile, and you'll notice that there's this automatic configuration. Now if I don't have it selected, let's say I have Slicer Prusa Edition, there's a bunch of settings here that you need to fill in. You don't actually have to fill them all in depending on what you're doing, but a lot of them are required, and if you don't fill them in, or if you fill them in incorrectly, you're going to have print quality issues, and it may not even take a time lapse. But by choosing this automatic configuration, you know that the right settings are going to go into Octolapse. Now, it is compatible out of the box with Simplify 3D and Slicer Prusa Edition, or Slick 3R as some people like to call it. It's also compatible with Cura, but you got to do just a bit of work. There's some code that you have to paste in either the start or the NG code section, and I've gotten a lot of help with that, and I'm going to do a detailed video on this, and I'm going to explain how this came about and what it actually does. But Cura, just know you got to do a little something to make it work, and these other two will just work. So let's pick automatic. We'll save. All right. Now if I were to print this was sliced using Slicer, it would just suck those settings out. So there's really nothing else to do. But it's not very impressive because it just prints, you know. So I'm not going to show it in action, but we will run a print through later. Now the third thing that I have done to simplify settings is it's actually something related to the camera profile. And a lot of people complained about the camera settings, adjusting the contrast and the focus, especially the focus, as well as a couple other variables, that it's difficult, the settings were hard to adjust, you had to have more than one browser window open, and I was very aware of those when I programmed it. As a matter of fact, I kind of crammed those settings in anyway, so I didn't take a whole lot of time to make it user friendly. And now I've had some time to go back and improve that. And you can get to it in two ways. You can click on your camera settings, and they're down at the bottom like they usually are. You can see I've got a nice little preview. There's nice little sliders here. Let's ignore the camera profile. Right here, this shows your active uh, your cameras, and if you pick one and click on the gear icon, you get a shortcut just to this setting screen. It's a real quick way to get in here and get to your settings in a hurry. Not sure what happened there, but again, this is a beta version. There we go. I probably clicked it too quickly. So as I adjust these settings, this preview updates almost immediately. You can see it doesn't update until I stop dragging it for a second, and that's just so we don't inundate the server with thousands of requests. Autofocus turns on and off, and all of these controls are exactly the same as the ones that were on the old camera page, but now they've got nice sliders and they're limited and there's help links, so that should make it just a bit easier. And the other thing I've added to make everyone's life a little bit easier is this defaults button. A lot of people, when they're changing the settings, especially for the first time before they're familiar with their camera or the lighting conditions, you can get into a situation pretty quick where your camera image is just horrible. I can crank the gain, I can crank the sharp, I can change things in a way that make my image horrible. Now, what do I do to get back to the original settings? Well, this default button, it's a little bit misleading. It's not guaranteed to reset your camera to the defaults, and it's just because I can't seem to get the right numbers from MJPEG Streamer at the moment. Sometimes I get values that are impossible, that are outside of the range. So if I get one of those that's outside of the range, I set it to the middle pretty much. And for my camera, it works perfectly. Click default, boom. And that's the default camera settings. Actually, except for the zoom here. The zoom should be down all the way by default, but as I said before, it's not perfect, but it's pretty close. Another nice little feature, if I make a change and I decide it didn't improve my quality and I don't really want to save it, and I've changed my camera, you can see right here that it's changed the settings on the camera. If I hit cancel, then go to the control page, you'll see the image is back to normal. So it undoes all the changes that you made while you were playing around if you cancel it. Hopefully that makes everything a little simpler for everybody. And that is the extent of the settings reduction that I've done right now. I hope to do some more cool stuff. I'm looking to have an automatic printer configuration tool, or a semi-automatic printer configuration tool that pretty much sets all of the values, or most of the values, as many as I can get to work in the printer profile. But we're going to have to save that for another release. So that deals with problem number one, config. The next problem I mentioned was time. Octolapse adds time to the print. Now, it doesn't always add a lot. It can add a lot, and it depends on so many things. Where is it stabilizing? What shape is your print? How tall is it? It really depends, and it's hard to calculate what it is. And my numbers don't necessarily agree with other people who've said that it adds, a certain percent. I can tell you it's all over the board. It's so print dependent. But there are definitely ways of improving this. So the stabilization profiles, the reason I combine those with the snapshot profiles is because some of these new stabilizations that I've written to deal with the time and the print quality are kind of intertwined with the trigger mechanism. So I combine those two so it would be easier and we wouldn't have to go back and forth between two different profiles to get everything set up. Let me open it up, and you'll see right away there's a new setting called stabilization type. And every previous stabilization was what I'm calling real time, meaning it operated in real time. It reads the G codes as they're coming in and it decides to take a snapshot. But because it's in real time, it doesn't have any knowledge of the G codes that haven't yet printed. So there was a lot of limitations on what I could do and the kind of stabilizations that I could write. So I've added a new set down here. There's two new ones, and we're going to start with this one, minimize travel. Obviously, the thing that's taken the most time on your average time lapse is just moving the print head from where it is on the printer to where it's supposed to be. And because Octolapse previously was real time, there was no good way to make it smart enough to minimize how far it had to go. But I've written some pretty fast algorithms in C++ that can parse the entire G code file and basically simulate it running through the printer based on your settings and look at all the G code to make the decisions about where to take, uh, when to take a snapshot. So I picked this, and these options haven't changed. These are the same options that you have with the real-time stabilizations. You can pick any of these options. Actually, you can't choose disabled. Let me show you that. That's the only option that goes away, is disabled. And once I have it, this is set right now to stabilize in the center. I've actually got one that's pre-configured to be in the back left. Let me pick that. You can look at those settings. So it's set up in the back left, and then I still have a trigger type option, but I can't choose anything but the layer trigger, because that's just how this works. It takes one picture per layer, so there's no way to use a timer or a G-code trigger here, and in fact, it doesn't really make sense. Now you can still apply a height restriction. If you want to speed it up even further, you can say I only want it to take a picture every 1 millimeters, and that will cut down on some time. I'm not going to do that right now. Let's just leave that at 0. I can just cancel this. All right, so I have my minimized travel done, and I've got a vase here that I've sliced. Let me switch to the slicer so you can see what it looks like. So this is the vase that's in that G-code file. Let me slice it real quick, and we'll look at the layers. Now, my stabilization is set to stabilize in the back left, so that's somewhere over here. So if we were going to minimize the distance that your printhead had to travel, we'd probably pick this spot right here, so that it would be as close as possible. I know you're saying this is a vase mode print. Why would you ever do this? And you're right. But later I'm going to show you a new way that we can actually stabilize in vase mode and have it work pretty dang well. But let's stick to the minimized travel. Let's go back to Octolapse here, and we'll print this. And you may have noticed here when I switched from this stabilization or the old school stabilizations to the new one, I get a new option down here, snapshot plan information. And a snapshot plan is what Octolapse creates when it pre-processes your G-code. It's just a list of all the places in your file where Octolapse is going to take a snapshot, where it's supposed to move to, and where it returns. So let me run this. And when I click print, you might notice a little pop-up appear for a second. That's the progress bar for processing the G-code file. It goes by really quick, so you'll have to pay attention. On a Raspberry Pi, it takes a little bit longer. This takes about 6 or 7 seconds to process on a 3B Plus, but it's really fast on my desktop. So, boom, done. And you can see it's going to take 799 snapshots, and it shows you all the positions and how far along it is in processing. And this isn't updating quite right on my development machine because it goes so fast that there's really no time for it. It just is waiting at the end. But you'll notice here, it says Octolapse is the extruder's gonna be here, and it's gonna move up to this snapshot position, and then it's gonna move back. And you don't actually see the initial position because it's exactly in the same place. I might make that bigger so you can see it. And did you see how it just jumped? Here, I'll change it around. So between these layers, it jumped. And why is it doing that? Well, let's animate the whole thing and you can kind of see what it's doing. So it's playing through each of the snapshots and it's showing you where it's going to be. And it's actually tracing the outline of that vase at the point that's closest to that dot. So it's only moving from here to here and not, say, from here to here, which is saving you quite a bit of time because of that reduced distance. Now, the closer your print is to this point, the more time you're going to save. And let me go back to Slicer. You can see how the closest point changes with the print. So it's pretty predictable, actually, where it's going to be when it takes a snapshot. And the animation that we saw up here makes it pretty obvious, too. And you can kind of get an idea of what the time lapse is going to look like, right? it's going to be right. Basically, it's going to be stabilized as though you had used the regular layer trigger. All right, so that helps with my time, but you might be saying this doesn't help that much with quality. It does take a long, the extruder's got to move out of the way. That takes time. There's some plastic oozing through it. You've reduced it, so you maybe improved it a little bit, but it's not a huge leap in print quality. Well, you're right. And because of that, I thought of and created a new stabilization, another new stabilization. I'm calling it lock to print or snap to print. I haven't really decided what I'm gonna call it. But the idea is that the extruder will never move away from the printed part. And so in this case, let's say I want to stabilize as close to the back left corner as I can. Now, I'm not allowed to move off the print. So what happens when I stabilize? Well, it would stay at this same point where the previous stabilization would have started to move, but it's just not allowed to move. So it just takes a picture there. And if we look at some of the settings for this new stabilization, lock to print, I can choose where I want it to be closest to. So back left right now. And this is a little complicated to explain what this means, but in order to choose a point closest to the corner and to make it a reasonable and fast process, what it does, it's going to find the spot on the y-axis that's the closest to the back left. And if there are ties, like if there's a couple spots that are just as close to the end of the y-axis, then it's going to start moving closer to the left on the x-axis. So depending on which one you pick, you'll actually get a pretty substantially different looking time lapse. But what this is basically saying is I would prefer it to be closer to the back than to the left, but try to do both. And there's another option that I'll show you a little later. This is for people who really, really want good quality. This combines these two ideas and saying it's not allowed to leave the print when it takes a snapshot, and it will take a snapshot at the point where the feed rate is the fastest while it's extruding. And what that means is it's typically going to stabilize over infill or interior perimeters, but it's rarely going to stabilize on an exterior perimeter, unless you're printing a vase mode print or something. So this means if it messes a part of your print up, it's probably going to be infill. It's not going to be the exterior perimeter. But it comes at a cost. Your time lapse won't be as smooth if you use this option in general, because if you look at each layer, the closest infill to the back left, the position might change dramatically and kind of unexpectedly if you look at it. But let me run this. I'm going to save it. Print this face mode. We'll generate some snapshot plans. Here they are. Now how does it stabilize? You'll notice that it doesn't have that snapshot position anymore because it's right over the print. It's basically doing something similar to what our previous stabilization did, but it's taking a snapshot right there. And I've actually got a movie here. This is a time lapse. Now my lighting's pretty bad. I wasn't really trying to get the video quality great, but it does show you what this stabilization does. So let me play it. See how it's locked right onto the print. And I was able to take this time lapse in less than 250 milliseconds per layer. That's all it added to the print. So it wasn't a whole lot of time. I could calculate it out, and I've actually got it in my notes exactly how much time it added, but very little time was added to this print. And I have to say, after I got this tweaked and worked out all the bugs, I had a hard time telling the difference between this vase that was printed with Octolapse and a vase that was printed without any time lapse at all. So I thought that was a really good test of the quality improvement of this particular stabilization. Vase mode, that is tough. That's tough for Octolapse. You'll see every defect on the surface, and in this new mode, at least with my printer, I really could not tell the difference. Now, I have to admit, if I looked at it in the light with magnification, I could see that one edge was a little flatter Although it still looked good, but it looked a little different than the other edges, and that's where it was taking a picture. So there was some difference, and I can tell you it's proportional to the amount of delay there is in acquiring your snapshot. When I worked out the bugs in my camera and increased the lighting and reduced the exposure and the delay, it pretty much went away. So now I still probably wouldn't recommend using Octolapse in base mode. This is kind of a proof of concept, but it did work, and it worked pretty well. And if somebody wanted to use it every time, um, I think it'd be fine. Now for something like a Benchy, it's going to be even better because uh, you'll be able to run Octolapse and you really won't notice anything. Now I have a video of Benchy, and you can see that there is a trade-off here, and the trade-off is the time-lapse quality. See, it's not 100% stabilized, and this is before I got all the kinks worked out, so there is a little bit of smut here, but it was locking to the back left as close as it can. So this is almost, it reminds me of a video from Octoprint where the time lapse just happens to line up pretty well. Well, this is forcing it to do that, so it'll line up as well as it can. So you have seen now the three improvements, or the three main categories of improvements, and I'm trying to add more features. And I want to thank all my patrons for all your support. It's been great. If you've made it this far in the video, bravo. It's some of this stuff is a little boring, but it's exciting to me, and I'm glad to get it out, and I'm glad to share it with you all. And leave me some comments, leave me some feedback. Let me know what you'd like to see. What do you think of these new features? And how would you like to see Octolapse evolve? Thanks. Former Lurker checking out.